And we're on. Hi, everyone. Thanks for joining. People are still kind of trickling in, so we'll get going in a minute. All right, so today we're talking about serving vector data. Please let me know, anyone, if you can't hear me. I suppose everybody can at this point. And let me know if you don't see my screen share for some reason. Okay, so today we're going to be talking about serving vector data. Somebody has raised their hand already. I will mention that I probably won't be answering questions throughout because that'll be a little distracting, but the Q&A section is always open. Drop your questions there if you'd like to. You can also message on the chat if you want to message privately too, that's fine. I can get to those at the end, but during the presentation, I probably won't be answering questions unless there's some sort of technical issue that somebody has. All right, so today we're going to be talking about serving vector data with Geoserver. This is sort of the second part to a webinar I did just a little while ago on raster. Serving rasters on Geoserver. So some of the information I'm going to share is sort of the same. There's a couple of the same slides that I'm going to be sharing, but the core of this webinar is really about vector data. So I'm not going to touch at all about talking about aerial photos or anything like this that we would be sharing on Geoserver. And also, me, as an introduction, my name is Cliff Patterson. I'm the CEO of Luna Geospatial. Okay, so a little bit about us, what we do. We are experts in open source GIS and software development. We do consulting and training on a variety of open source packages. We do regular training for QGIS and PostGIS, and we're going to be starting to do a little bit more on Geoserver and GeoNode in 2023, so look for that. We also provide training support, ongoing support for companies and organizations who use this technology. We build a lot of software. We build a lot of custom web GIS applications, dashboards, any type of data portal, any type of really heavy sort of database-driven application is something that we excel in. And we also set up GIS servers. So for those of you who sort of want to move to open source GIS and want to actually have a server in the cloud, we can set that up. We provide training, support, backups, everything imaginable to get you all set up with an open source GIS stack. We don't spam, but we do have a newsletter. If you want to stay in touch, this is really the best way to this and our social media accounts. Really good way of staying in touch. We always post everything that we do on social media, as well as we send out a newsletter with some additional little tidbits. We try to send maybe 1, 2, 3, maybe the most, depending how many webinars we have. We usually send a monthly newsletter and sort of a reminder a few days before webinars. We really do try not to fill your inbox with messages. So sign up at lunageo.com/newsletter and we will stay in touch. This is bigger than this webinar. This webinar on Monday is going to be a lot of fun. We have Mike Golbo from is going to be presenting at QGIS in the wild on his use of QGIS, and that is also going to end up on our YouTube channel after that. But definitely join on Monday. Ask some questions. It's going to be a lot of fun. So our last one with Kurt Menke is already up. So if you want to relive that magic, log in. But go to lunageo.com/webinars. To learn more about and sign up for this webinar. Looking forward to seeing you on Monday. Also, some trainings happening next week. If you or anybody you know want to sort of have a crash course in QGIS, I do kind of like this 5-hour, here's how it works introduction. We go through about like 6 or 8 different tutorials, and we usually have a follow-up session. I usually have a follow-up session with every student in the class if they want. And then we have the following week, we're going to be doing our advanced QGIS 1, which does a little bit more stuff like network analysis, georeferencing, geocoding. So sign up for those if you're interested on our website at lunageo.com/training. Okay, enough with the commercials. Your feature presentation. So we're going to cover just some of the basics, like what is Geoserver. I'm going to give you just a little bit of an overview demo. So instead of giving the demo at the end where I'm like, look at all the things we created, I'm going to show you kind of just the problem that we're going to try to address by serving vector data through Geoserver. Then I'm going to dive into how it's done. So I'm going to talk about serving vector data via materialized views, which is something I really like to do. And then we're going to talk about layer symbology. We're going to make a base map with group layers. We're going to secure vector layers, and we're going to talk a little bit about caching via GeoWebCache and consuming vector layers. So this is going to be mainly in QGIS. We're just going to connect to the endpoints and show you how those work. And then following that, we're going to do our little Q&A session. So if you have questions throughout, feel free to drop them in the Q&A section on Zoom, and I will try to address all those questions at the end if we have time. So I like to sort of explain who this webinar is for as we get going. It's really for people who have never used Geoserver. So if you're a super advanced user and you're looking for some advanced technique with some obscure extension installed on Geoserver, this probably isn't the webinar that you're looking for. But if you're new to this, if you're not familiar with this technology and you sort of want to dive in or at least just have a glimpse of what this can do, this is the webinar for you. So people have never used served vector data via Geoserver. We're looking for you to. Also, people who have used Geoserver but might want a better recipe for serving vector data, something that's going to be a little more snappy when you're sharing your data. I also always target these to people who might be paying for a rather expensive proprietary GIS server. So you might be looking at some sort of cost-effective alternative to your current solution. So this is a really good way of sort of evaluating that and seeing what this technology can do. So big question, what is Geoserver? So Geoserver is an open source server for sharing geospatial data. It's designed for interoperability. It publishes data from any major spatial data source using open standards. So this is right from the Geoserver website. And I've just sort of highlighted some of the important bits here. This is an open source product. And it's really mainly aims to share geospatial data. One of the things that's really nice about it is this interoperability, right? You can share the data because it uses open standards. You can share data through Geoserver to whatever GIS you're using, whether you're using proprietary or open source. If it supports open geospatial standards, you will be able to consume data that you publish through Geoserver. And the nice thing is that it supports so much. There's also extensions always being built and added to it that support a variety of different formats. And in this webinar, we're going to look a little bit more at some of the vector formats that it does support and some of the extensions that we can use within Geoserver. All right, so the interface of Geoserver. Once you have it all installed and ready and booted up, you're looking at this screen when you first log in. You're usually accessing it for using the port 8080, but once you have a proxy server set up and all this stuff, you can just access it from like geoserver.yourdomain or something similar. So when you log in, you get this nice sort of dashboardy type presentation where you get to see all the layers, stores, and workspaces that are within your Geoserver. You of course have login is required to see most of the admin portions of this web access tool. We can see all the different service capabilities, and as you install extensions, if you install additional extensions to support things like different vector tiles or different types of service capabilities, these will be listed in this section. You can access the logs and information about the server in the top left. Below that, you can manage your data, you can manage your workspaces, stores, layers, and styles. Below that, you can change any of the service-specific configuration. Under that, you can change some of the global and raster processing settings. And under that, this is something that we're going to talk a little bit more today about, is managing tiles and caching location, size, and grid set, and so on. And lastly, and perhaps most importantly, we're going to talk about security. We're going to talk about how we secure these layers within Geoserver. Okay, so I'm going to give a little brief overview of the problem that I'd like to address here today. And the problem is this. Well, here we have open data that I've pulled for Kamloops, British Columbia. I love any open data set that I can pull off, that I can get parcel data sets. In Canada, sometimes that's not the easiest thing to acquire in some locations, but here I have it. I have all the parcel data set, and right now this is all being pulled from a PostGIS database that I created. Just a little demo database. I pulled in building footprints from OpenStreetMap, and I pulled in a bunch of layers from their Kamloops' open data, including parks, property parcels, streets, neighborhoods, and I styled them. And we have this base map that kind of works okay, and we can load things, but we're pulling everything directly from our database. We kind of want to serve this out as a service, this map. So the solution that I put together is exactly this. And what you're looking at right now is a base map. It's a group layer in Geoserver that takes the exact same styles that I have within QGIS and serves them out. And yes, I know there's no water here. I don't have the water body layer put on here. That would probably be the next thing that we'd want to add. But this is pretty zippy. And you see that we're using the same server for both connections. So if I come back to something like the PostGIS connection, so this is pulling vectors, obviously, as I pan and zoom, it's pulling it from the database, whereas this is pulling in tiles. So this is a WMTS service. It's a cache service, fairly zippy. And you can see we have our labels on streets and things like this as we load it. So it's working out quite nicely. And we can zoom out. And you can see that even at this zoom level, it's quite nice. And one of the nice things about this is that as we go into, let's log back in. So as we go into our Geoserver, we can see that we have, if we go into our tile layers, we can see now that for the Kamloops base map that I created, we've already created 41.62 megs of cache. What does that mean? So if you were in the last webinar, I'm going to explain this as we move on. But as we zoom in to this base map, it's actually building the tiles as we go, which is nice. So when we go back to Geoserver after loading a new area and refresh this, now we're up to 45.92. So this is the setup that we want to create. And I'm going to run through the process of setting up this base map on Geoserver. All right, so the first thing we're going to need to do is we need to serve our vector data in Geoserver. So to do this, as a little bit of an overview here, Geoserver supports out of the box a directory of shapefiles in terms of creating a data source for your vector data, Geopackage, PostGIS, shapefiles like individual shapefiles, as well as other types. Now, you can also use Geoserver extensions, and you can see this a little pop out on the right here for vector formats to support a number of different data sources, including DB2, H2, MySQL, Oracle, SQL Server, MongoDB. So you can really pull data out of really any enterprise system where you have data stored and pull that into Geoserver. So if we're going to be serving a shapefile, so the first step we need to do is we need to create a data store. So when we create the data store, we're going to name the store and we're going to add the shapefile location. And here on our server, where it's just going to be located within our sort of demo data folder, and I'm pulling in these healthcare centers, and it's an individual shapefile that I have on the server that I'm going to pull in. We press save, we publish the layer, and then, oops. Now, as we publish the layer, we need to set things like we need to set the layer name and title, the declared CRS if needed, and we need to compute the native and lat long bbox. Save and then preview the layer, and you guessed it. Now we see the points for this layer that we just served. Easy. So you can do the same thing with Geopackage. So you create a new Geopackage data source and you save it. And you can publish one or multiple layers, that's supposed to say from the Geopackage. Note that each layer has to be published individually. Okay, set the layer name. And then the next thing, once we have the layer published, once we're publishing the layer, we set the name, we compute the native and declared bbox, and we save and preview the layer. And just like with the shapefile, we have the layer shared now, and it's working great. So what if we want to share multiple files? Well, what's really nice about doing something like with Geopackage, I sort of tend towards using Geopackage whenever possible, is that you can serve multiple layers from a single shapefile directory or Geopackage. So if you're going to do a shapefile directory, literally just throw all your shapefiles into a directory, share it out, and then you'd be able to publish any of the shapefiles within that directory. Likewise, with a Geopackage, if you point towards a Geopackage, and in the example on the right here, I'm showing you this, is that I have a Geopackage that contains parks and tourism accommodation. And down here, I'm just showing you all we have to do is press this publish button, and then you get to that screen where you're publishing the layer, and you can start adding all the information. Now, I will say this is best for read-only data that will not change very often. I think if you have a data set that's changing on a regular basis, it is a real hassle to have to go in, FTP or SFTP some new data into a server, go in, republish or drop a layer, and then re-add a layer, and then set up the style and all this. It can be quite a pain in the butt. So what's nice is we can also serve directly from a database. And this process would be the same if you're using something like SQL Server or Oracle or DB2. The process is quite similar in that you're connecting to the database, and you're not just connecting to the database. One thing you should note is that you're connecting to the schema within the database. So the first thing we do when we're setting up a vector data source is we name the data source, we enter the host, port, database, schema, and credentials. One common mistake that people will do here is that if they've created multiple schemas within their database, I often will create a structure where I have one for boundaries, and then I'll have another one for parks and recreation, and so on. What I will often do is I will forget to put that in the schema right here, and I'll leave that by default. It says public, and I say, oh my gosh, there's no layers. What am I going to do? Always remember that you have to go back and change that schema. So then when we're going to publish the layers, you publish the layers individually. So once you create the store, the next screen you're presented with is new layer. Which layers do you want to publish? So in this case, I'm showing you just that I'm publishing the neighborhoods layer from the database. And then you can preview the layers once you've published them. And what you can see here is a preview of the neighborhoods in Kamloops that was published from the PostGIS database. So that's pretty much the basic process of publishing vector data in Geoserver. Fairly straightforward. You connect to a data source, you publish layers from that data source. So the big question then is, when do I use a file versus a DB data stores? Okay, so they say that you get a performance increase when you're using files versus DB. Maybe, yeah. I think I do notice a difference. I rarely use files within a production environment. There's a couple of cases where I kind of like to. I have an idea now. I want to push it. I have a very large soil data set for Ontario, and I thought this would be kind of cool. Let's see what happens if we serve it out as a Geopackage versus serving it out as a fully cached PostGIS layer. What would be the difference? So I don't know. For me, the jury is kind of out. I think that the hassle of having to update any files makes me lean towards a database most often. But if you have 10 layers, you're serving them up for some web map application, they're never going to change. Files are a great way to go. Throw them all into a Geopackage, serve it up through Geoserver, and you're good, and you're done, and you don't have to think about it. Now, one of the things that's nice about a DB connection, and this is good and bad, is that you can actually permit editing via WFS. So WFS stands for Web Feature Service. So with this service, you're actually serving out the vector data to a client. So what somebody could connect with QGIS to your Geoserver with a WFS connection if their credentials in Geoserver allow them to edit. And if that store was set up properly with editing privileges, then you could actually edit the data. Bad thing about this is that if you set this up and you forget and you leave WFS wide open to the world, anybody who connects to your WFS connection can now make edits to your data. And if those data live within your database, they're basically get a complete access to that data set on your database. That could be bad. Now it's easier to update layers with a DB connection. So the scenario would be, okay, we added a new park. We need to change the layer. Well, in a nice sort of enterprise environment. You open up QGIS, you edit the park layer, you add the new park polygon. We're happy, we're done. That new change is on the map. With a Geopackage, is you'd update the Geopackage that you use for the web map application. You'd upload it to the server, delete the old one, add the new one. Everything should work as long as you haven't changed names to anything. And that's the process. So it's one kind of manual, the other one kind of easy. All right, so another thing that I've been doing a lot when I'm serving data is I want to serve it, I'm kind of saying it's like indirectly. I don't know if that's clear or not, but I'm serving data as materialized views in database. So what's a materialized view? So this is pretty much the setup that I like to do now when we set up a web map application for somebody with data that they don't really want to expose every single change they make to the data right away to the web map application. Now you could make a copy of it and only share the copy of the table, but that's kind of silly. Because a database can do something called materialized view. What's a materialized view? Well, a materialized view is a query that you run against your database, and you say, show me all rows from this table where the color is red. And then you've created sort of like a temporary table in your database that just has the rows that you've selected. Now, the good thing about this is that you can build indices off of this as well to speed up performance. You can pretty much do everything you can do with a table with this materialized view, except for editing it, of course. So if it's read-only data and you want to serve it out quickly and you want to be able to sort of protect yourself from exposing every single edit you make, it's a great way to go. So we serve out the materialized view just like a layer. It shows up when we connect to a PostGIS schema. We serve that out as web services. So some of the advantages, it's really easy to update the layer with the refresh materialized view statement. So when you're ready, you can sort of do this. So I kind of call these like releases. They're not really releases, but you could have, say, all right, everybody's been making edits on the parcel data set. We obviously don't want to release these in real time to the public because we want to make sure that everything is done correctly. Once those new changes have been approved, we can do a release. Then all we do is run the refresh materialized view statement on that table. Boom, you log into the web map. That new layer is now updated. So you could also filter tables with the where clause. I gave that example of show me all rows where the color equals red. Now you're going to have a layer, and it's the red one. You can include new or modified fields. So imagine this. You can add things like area or length or perimeter to a polygon. You could add something like the centroid coordinates for a polygon, and that doesn't have to be a real field that exists anywhere. It can be something that just exists within the materialized view. Now, of course, why not views? Well, if you're going to run a regular view on this, every time you pan and zoom, it's making a request to the database for that query. So the query takes like 17 seconds to run. That's going to really hit performance, right? It's going to be unusable once you start using it. One of the things I really like about this too is that you can remove private fields. So again, think of a parcel data set. If you have something like landowner information, you don't want to share that out to the world. You want to sort of protect some of these private fields. So you might only want to share the ID, the geometry, and the address, maybe the roll number or something. Well, you can share those fields out, and then you can keep all the other fields private. The other thing that I really like about this is you can include complex spatial and non-spatial joins without impacting performance. So again, this is an example. If you're going to set it up as a view in the database, you're going to make, every time you pan zoom, you're going to make this request to the database for using this query. Whereas when it's a materialized view, you've done that already. So even if it takes, 10 minutes to run the materialized view to refresh it, that's fine. Because in the end, you're going to have a table that's very zippy to use. So I really like this. So let me just show, last thing that's really nice is that you can transform the CRS. So if you want to transform to like Web Mercator and have all your data in Web Mercator so that they're a little more zippy when you're building them into a web map application, then you can do that as well. All right, so I'm just going to show you just a couple of the commands that we do. Just if we're going to serve the Kamloops parcel layer as a materialized view. To create the materialized view, it's very easy. You just run create materialized view. I have a schema called demo. So in demo, I'm going to create a table called property parcels. And all I want right now is the ID, the geom, and the address. From obviously, I have this table called property parcels. It's within the boundaries schema. And I'm going to have that. So now when I run this, and now I have a materialized view that has all of my parcels in it. So if we can compare the two, the materialized view and the source data are exactly the same. Obviously, I've just styled them differently for visual effect here. So you can see that the one on the left is the materialized view and the one on the right is the source data. They're exactly identical. But what if we add a new polygon? That's a big parcel in the middle of the water that I just added. And we edit this source data. Well, if we go back to our web application that's serving the materialized view, you're not going to see that change because you haven't run the refresh command yet, which is, as you can guess, the next step. So we run this refresh materialized view on this property parcels table. Next thing you know, the materialized view now contains that new polygon that was added. So in this way, you can sort of have like releases of data to your web map application. So as long as you're serving in Geoserver this materialized view, then you're in good shape. All right, so we've served a bunch of data. We've served a materialized view. We're very happy with it. We've done good work. But unfortunately, all of our layers that we serve get this sort of default symbology that Geoserver applies to them. It's a gray, boring polygon. Let's make it a little more flashy. All right, so when we're talking about styling vector data, the default method to create symbology in Geoserver is to import or create an SLD. An SLD is nothing more than this little XML file that you see below where you can update, change colors of things. And the interface in Geoserver has really improved with this in recent years. It used to be that it was just pretty much this form, but now you can actually, once you save a new style, you can now apply it to layers within the database from within this screen. It's really quite nice to work with. One thing that's nice is that just like we did with raster data, where we exported the SLDs for the digital elevation model, well, we can do the exact same thing with vector data, is that we can export the SLD associated with a layer and import it within Geoserver. So Geoserver can also support CSS, YSLD, which is a YAML-based style, and MB styling. And these are all via extensions. So if you install these additional extensions, you can do this. I sort of lean towards SLDs, and the main reason for that is that it's really easy to just export from QGIS. Now, the only thing I will say about exporting SLDs from QGIS is that they work. I think there's always been a version difference between QGIS and Geoserver in terms of the SLD version. Or something. Again, I'm talking about something that I don't completely understand, but the end result I understand is that sometimes the styles don't look identical. Sometimes you don't have the exact same font, or the text doesn't appear in the exact same location. And also there's things like when you're styling in QGIS, you have much more control over the placement of labels, whereas if you're styling a tiled service and there's a really big park, depending on your zoom level, you might have 4 different labels in that park that are identical. So at that point, you kind of have to think differently about styling layers on a map. But that's beyond the scope of this sort of discussion. Note that also that symbology only applies to WMS and WMTS services. So those are tiled services from Geoserver, not from WFS. So if you apply a default symbology and then load a WFS in QGIS, you're just going to get the default symbology that QGIS will apply to that layer. There is no symbology that is stored with a WFS. So to do this, style a layer in QGIS and export the symbology as an SLD file. Very easy. You just sort of right click, go into properties, export the style, save the style as an SLD, save it somewhere on your system. In this case, I saved the property parcels SLD. And then you want to import the SLD file into Geoserver, and that's right here. You just can choose a file, you press the upload button, next thing you know, the whole parcel style shows up. Sometimes you might want to change things like the name. It might show up just as something like single feature. You might want to just change, or single polygon. You might want to just change that to say parcel. And you can check the preview of the legend here. If you click this button, you'll see the preview. And then you want to, in the publishing parameters of a layer, you want to change the default style to the newly created. So in this case, I went into property parcels. I went into the WMS settings and I found the default style and I changed it from default polygon or whatever the default is to property parcels, the new style that I just created. Now you save and you preview and lookity-look. It looks exactly as it does within QGIS. So this is a fairly simple one. It's just an orange outline. Again, you can have multiple levels. You can get fairly complex with these styles. But what I'm showing you now is a fairly basic style. At any zoom level, it's going to be just these orange lines. So what do we do now? We want to make a base map with all of these layers. So the base map we want to create is this. And this is what I showed you at the beginning. This is my PostGIS. The PostGIS is the source for this, and we've created this, kind of nice base map, if I do say so myself, with the parcel data sets, the building footprints, the parks, and so on like this. So how do we go about doing that? Well, first thing we need to do is we need to load and style each layer. And you'd see here I have the 4 different layers, the roads, the building footprints, the parks, and the parcels. And then we want to go into and create a layer group. And we create the layer group by adding all the different layers. And you can see I've added the layers, and you're going to control the drawing order for these layers. Then you want to preview that layer. Well, what we created quite simply is that base map, and we added all those layers with pretty much the same styles, and we're able to see those. And you're able to load the layer as a WMS in QGIS, but you can also load as a WMTS, and it loads quite quickly. All right, so now we're going to talk. We've loaded some data. We've loaded it from a database, and we want to make sure that everything's secure. So this is pretty much what we did with rasters in the previous webinar, where we want to create users, and users are actual login users to GeoServers, and roles, specific roles for different types of users. So you can create one for admin, read-only, editors. I'll typically create one for staff, and it's like a read-only staff group, so that, if you create a new user and add them to staff, well, they'll have the ability to read anything within GeoServer. And you can also create groups, and groups are groups of roles. All right, so some of the basic settings that I'll always do is that we can set the data level security. So that's exactly what it sounds like, is what can we do with all the data sources, data stores and layers, published layers within GeoServer. So rules can specify the workspace. I can specify the layer and groups. It can specify the access mode, read, write, admin. And it can also specify the roles that can access the specified data. So note, for PostGIS layers, use the database permissions also on the GeoServer user that's accessing PostGIS. So when you're setting up that PostGIS connection, you do have to think about whether or not you want to have these layers be editable or not. I always recommend that within your database, create something like a GeoServer user, or if you're creating a web map application, have some sort of web map user, and then grant them specific rights to the layers. So if you want a layer to be served through GeoServer, it's only going to be read-only from the database. Your second line of security beyond the GeoServer security are the permissions that you assign to that user within PostGIS. So if you want it to be read-only, make that user only have read-only permissions. Now, If you want them to have edit permissions, then you need to make sure that the user has edit permissions on those layers. Because even if in Geoserver, you said admin users have the ability to write the data, if the store was set up with a user that's only read-only, you're going to get errors and you're not going to be able to edit these things. So this is sort of, you have to think both when you're connecting to a database, think of the database level security and think about the Geoserver level security. You can also lock things down at the service level. So secure data access at the service level, you can lock down WMS, WFS services. This is really smart to do for all the major services within your systems. I always have the star.star for the group admin, and the admin, what that means is that every single service can only be accessed with the admin credentials. And then I do specific ones for different types of services like WMS. If you want the staff read, anybody who's a member of staff read role to be able to access the WMS service, and that's fine. And for us, we would do the same thing in this scenario for WFS. If we were going to create, we would allow read-only access to the WFS, but for write purposes, if we have any connections where we can actually write to the source vector data, then we want to make sure that only admin or specific users have access to that. This really does allow us to turn services on and off, not only for specific users, but for everyone beyond admin. We can lock down entire services, and we can say, like if I did star WFS.star for admin, that means only admin users can access that service, the WFS service. Everybody else can only access, let's say, WMS. So you really have a lot of control here. This is where it gets kind of confusing, especially when you're working with vector data. You have, security level at the database, security level within Geoserver, and you also have to think a little bit more with vector data about what services you want to open and how you want to open those. Because Geoserver, if it's set up, like if you connect to Geoserver with your admin database access, anybody, and then grant editing privileges to your read-only group by accident, anybody in your read-only group can now edit all of your layers within the database, even though they themselves on the database side don't have that permission. So something to think about. Okay. Let's talk about caching. So security is a big discussion. That's something I can always help with if somebody wants to reach out if they're needing some support on that. All right, caching layers with GeoWebCache. So just like when we work with raster data, we want to be able to cache our layers within Geoserver. This will improve performance, and this also kind of controls how the users have access to the data, especially in terms of the CRS that they're going to pull the data in. With WMS, you can sort of transform on the fly. It kind of makes Geoserver work a little bit more. But if we specify with something like a WMTS service, the CRS and the type of tile that we're going to create, whether it's a PNG or a JPEG, this will really increase the performance here. So caching layers with GeoWebCache. The first step you really need to do is just modify the caching settings for each layer. And you can do that just by accessing the layer properties and then going into the tile caching options there. So the first thing, you do have to enable tile caching for each layer. That's usually done by default. When I'm working with vector data, I'll typically only serve out in PNGs because they support transparency. And I will set the appropriate grid set. Now for this one, we're using BC Albers. So I'm going to set that to EPSG 3157 for this area. And then I can connect in QGIS to the WMTS service. So you can see in this screenshot here, we're now connected and we have access to all the different layers that we want within that base map. And they're all being served out as a tile set that's in EPSG 3157. So it looks like we're ready to go. So once we have these loaded, I showed you this already in my demo at the beginning, is that now we can actually look at disk usage for the different layers. So as we load them and zoom in and out, the tile and click on, if we're in the tile layers section of Geoserver, we can see how much disk space has actually been used on these layers. So what about consuming vector data from Geoserver? We can serve data as a WMS, WMTS, and WFS endpoints for vector data. So WFS is an actual vector. So when you're serving out a web feature service, you're actually accessing the vector data itself, right? So you'll get the vector data as well as all attribute data and everything with it. Conversely, when you're accessing a WMS or a WMTS service, you're getting a raster tile. Now, there's still ways of querying a WMS layer, but you have to understand that you're getting raster tiles of the database. So I always explain this to people if they're not familiar with this. It's kind of like taking a picture of your vector data. It's taking a snapshot of your vector data and serving that picture out to your client. Whereas WFS, you're just getting the vector data. So if you want to even do analysis with that or export it into a local Geopackage and then do something with it, you're able to do that. Typos. Unacceptable, people. All right, let's talk about this. So consuming vector data from Geoserver. So just like we did when we were connecting for raster data, we want to create a new WMS, WMTS connection in QGIS. We want to name the connection. We want to use configurations instead of the basic authentication just to protect your passwords within your enterprise environment. And you want to enter the endpoint URL on the URL line. So this might be either the WMTS endpoint or the WMS endpoint. Now this works the exact same way when we're connecting to the vector data, and I'll show you this in a sec. I'll give you a little demo of that. So what's nice here is we're able to access the data set in 3 different ways. We're able to access it as a WMTS. This is the cached tile service, and we're able to access it as WMS. This also is cached in a way, but not in the same way as WMTS. And then there's the WFS. So you're actually accessing the vector data through Geoserver. All right, so let me go through some of these things, and then we're going to call it quits for the day. So I already showed you that. Oh, keeps on logging out. Actually, let's go to Geoserver. All right, so I already showed you this. I showed you the basic layers that we're able to connect to with this service. So I'm going to connect again to this service as the WMTS service, and I can load individual ones like the parks if I want. So if I load the parks, now we have just the parks loaded. So you can load these WMTS layers individually, or you can load them as that group. So I have the whole group on here versus just the parks. Kind of nice. Now you can also, I'm going to leave this on. We can also connect to the WMS connection. And again, now we have access to the WMS service, and we can load things like the parks. Now, the tricky thing here, this is the reason why WMS could be a little tricky, is that it gives you more options than you really, really want. So you sort of want to go, oh, well, I really want to make sure it comes in the right coordinate. So you have to set this. And this is where I've had problems. Also, when you're sort of trying to teach this to new users of QGIS, you're like, well, you got to make sure you set the right CRS. What's a CRS? That's why it's a lot easier just doing this WMTS, and it's also faster. So if I am going to load property parcels now I have property parcels coming in as a WMS service. So just as zippy, but it's a lot. I find when you're using the WMTS service is, I don't know, I prefer it. It's faster. You don't need to change a lot of the settings. And they kind of style a little bit better too, I find, when we're using this service. There's probably a very good reason for that. They're styling it at different levels, which is probably why this looks a lot nicer. So this is great. So what if we wanted then to access the vector data directly? And this is the thing that I want to show you, is that now we can access all of our data as vector data if we want. So I could add this data set, and now we're actually looking at the vector data. So if I go and identify, I'm actually getting the full all the attribute data for that. And the way it works in QGIS, of course, is as we sort of zoom in and out, it's going to make that request to Geoserver for the for every single polygon that intersects with the B box of this map view. So again, it's still quite fast, and it's a nice way of serving data out to individuals. If you don't want to give them direct access to your database, you can also control how they have access to. So how we use this, there's a lot of time a client wants to serve out a layer to one of their clients. So what we'll do is they also want to denormalize their data. So let's say they have a lot of lookup tables and their database is quite complicated. So we denormalize the table in that we create just a very basic layer that has, instead of lookup values as integers, it actually has the values themselves. So we create all those joins and create the table. And then we can serve this out through Geoserver. So when the client opens this up, they can see all the work that's been done. And then they can have a view just of the data without having to have lookup tables and all of this stuff connected. So you're able to sort of protect your database. Only really authorized users can have access to these data. But one of the flip sides of using a solution like this is if I'm going to now add property parcels from the database. So now this is to get confusing. The sort of pink underneath here is the parcels coming as the WFS. We have WMS, but now we have the actual source data. So the source data is something I can edit. All right, so I can add a new polygon here. And I've added a new polygon. You can see this is in the data set coming from the database. Now, if I zoom out, eventually the WFS layer refreshes, and that new polygon I have is now being served out through Geoserver. So WFS is nice because it's in real time. Whatever changes happen on the database, this is going to happen. So, but if I come back to something like my base map that I just created, and let me turn off this, and so now we're just looking at our tiled service here, we're not getting that polygon. Like it's not showing up. Now it is when I zoom in. So what's going on here? So I zoomed into a new level that I hadn't been before, and it's there, but when I zoom out, it's gone. And the reason for that is that if we go into the tile layers, we actually have to empty all this cache. I won't empty this cache because it's going to slow things down a little bit, but I'd have to empty this cache. And the other thing I've noticed too is that you also often have to close QGIS and open it up again because some of that cache is stored just within the local session. So likewise, if I look at, not this one, sorry, I think this is my WMS service. No, sorry, this is the, yeah, again, this one is also cached, so will only show up if I really zoom in. Oh, there it is. So it only shows up at certain zoom levels because I don't have those cached already. So because I zoomed in, then it cached this, so now it preserves this. So if you have a layer that is changing a lot, even if you're serving it out as a materialized view, you have to remember to come in here and say, okay, well, I've made some changes to this layer, I'm going to dump the cache. And there's programmatic ways of doing this, of course. But the easiest way is to log in, press empty here, empty the cache, and then all those new features will show up and you'll be happy. All right, well, thanks for hanging on. I did want to say that we have an offer that's expiring at the end of the month to set up a GIS server. We're sort of giving these away at 50% off for the first 3 months for any new clients. There's no long-term commitment, nothing sketchy like that. But this is really an opportunity for organizations to try open source GIS, to try our cloud-based solution. You can have PostGIS, Geoserver, GeoNode. We're also putting Mergin Maps, the community edition, on these servers. So you're going to have access to everything, and you can try a lot of the things that we've done in here. But we also want people to use this as they take it on. And we appreciate that it's going to be, it can be quite overwhelming as you take this transition to migrate towards open source GIS. So we provide a free sort of implementation plan. We do a kickoff meeting and talk through some of the issues that your organization might face in terms of serving GIS data, managing users, and so on. We provide a free 2-hour training session with this promotion. So we'll actually walk through the process of loading data into PostGIS, serving those data out through Geoserver, consuming them through a variety of different services, and also doing some of the basic stuff. So we try to fill your knowledge gap. If you're already familiar with QGIS, then we're going to focus a little bit more on PostGIS and Geoserver. And again, there's no long-term commitment. Even after the 3 months, it doesn't roll over into any sort of long-term contract. But it gives us something to talk about as you sort of get a handle on using this. So if you're interested, go to lunageo.com/servers, or you can also just email me, contact me in any way you wish, and we can go through it. So questions. It's not lighting up, which is fine, which means you've been wowed, which means I answered all your questions. All right, so if that's the case, thanks everyone for coming. This has been a lot of fun putting this together. I always like writing training materials and webinars because it really forces me to go through the process and document it. And I hope that this has been helpful in your sort of journey towards using Geoserver. So watch for more of these webinars. We're putting together our plan for 2023 already. So we're going to try to roll out a sort of similar number of webinars as we did in 2022. And focus a lot on Geoserver. There's going to be some on GeoNode. There's going to be some on more on QGIS and a lot on PostGIS. So that's kind of what we're going to be focusing on. But if there's anything you really want to see, always reach out. Come to lunageo.com. We have a contact form there. If there's something you really want to see in a webinar down the road, let us know. We'd love to put it together. All right. Thanks, everyone. Have a wonderful day.